Hello, my name is Allison Hardwick, and I will be presenting this quantitative study design researching how simulations affect learner retention. Let's start off with a brief introduction about simulations. Simulations are a technology that can be used to provide comprehensive training without the risks present in a real-life scenario. Some common examples of simulations are flight simulators used by pilots to learn how to fly different aircraft, or artificial human organs used by doctors to practice surgery and other complex medical procedures. Simulations are a great option for Air Force training because they are a consistent and low-risk option. A very important component of every airman's career in the Air Force is training. They must learn how to do their job effectively, efficiently, legally, and safely. The Air Force is also responsible for minimizing risk in training settings, which makes simulations a viable solution. My field focuses on providing training to Air Force contracting personnel. These are the individuals that write and manage contracts for things that the Air Force has to purchase. Contracting personnel purchase everything the Air Force needs, ranging from base supplies, computers, lawn mowing services, all the way up to complex weapon systems such as bombers and tankers. Simulations are applicable in this field because government funds must be spent appropriately and legally. This is a serious risk for anyone in the career field because if they spend government money inappropriately or illegally, they could face jail time. Furthermore, other Air Force units may not be equipped with what they need, which can be really dangerous in certain situations. Based on these risks, it's really important that contracting professionals are trained using the best resources available. The research question for this quantitative study is, what is the influence of utilizing simulations as a standalone method for software training on learner retention? The Air Force typically utilizes traditional computer-based training, CBT, modules to train contracting personnel, especially when it comes to learning how to utilize a new software. In this study, we want to explore if using a simulation instead of a CBT to present training on the new software system will improve learner retention. The content for the training course that will be presented to the participants in the control group and the participants in the experimental group will be based on the new contract writing software, which is called ConIT. The control group will learn how to use ConIT via CBT. This means they will be able to click through a course with text and screenshots on each page. The experimental group will learn ConIT via simulation by interacting with the system, actually clicking the buttons and entering the information to simulate writing a real contract. They will receive feedback from the course based on their actions and inputs to feel the consequences of their decisions. The actual information presented will be exactly the same for both groups, just accomplished through different methods. This study will involve 100 participants. It will utilize convenience sampling and random assignment. The study will ask for volunteers from the contracting career field and incentivize their participation by offering 8 continuous learning points, commonly referred to as CLPs. This incentive should encourage participation because all airmen, enlisted, officer, and civilian, are required to earn 70 CLPs every 2 years. Generally, 1 CLP is equivalent to 1 hour of attending a class. This offering would allow for the opportunity to earn more CLPs with less of a time commitment, making it highly attractive. Due to the fact that we are asking for volunteer participants, this means that the sampling is convenient because we are limited to a sample based on who volunteers. However, of the 100 participants, 50 will be assigned to the control group and 50 will be assigned to the experimental group. This assignment will be completely random. It would be best to utilize random sampling and random assignment to more closely utilize true experimental design. However, based on the confines of the environment and situation, the next best option is what this study will utilize: convenient sampling and random assignment. Data will be collected using a pre-test, post-test design, with the intervention occurring between the 2 tests. The control group and experimental group will take the same pretest. The control group will then receive ConIT training via CBT, and the experimental group will receive ConIT training via simulation. This is considered the intervention. After the training is completed, the participants will take the same post-test. The pre-test and post-test will utilize multiple choice questions to measure prior knowledge and learning outcomes respectively. It is important to test for prior knowledge because this can be a significant confounding variable if it is not accounted for. A confounding variable is anything from outside the study that influences the results. The post-test will also utilize multiple choice questions to determine what the learners retained from the training they received. In the chart on this screen, you can see 5 sample questions from the post-test that are designed to measure learning outcomes. The participants will complete the study in one session utilizing a single online module. Prior to the study beginning, each participant will be provided with a pre-briefing that asks them to certify that they have not yet had prior ConIT training or experience. The pre-test will also account for this confound, but we want to try to eliminate it as much as possible. Given the amount of airmen in the contracting career field that have not yet received ConIT training, a large enough portion of the population is still eligible for the study given this criteria. They will also be given instructions to report to a lab at a certain location on a specific day during the specified hours. Once the participants arrive at the lab, they will be given a link, a username, and a password to sign into the online module. The module that they access will either be a CBT or a simulation assigned randomly. They will begin with the pretest, then proceed to the training, and finish up with a post-test. It will be a seamless experience that flows from screen to screen. The students will be able to go back to any portion of the training that they want to repeat, but once they access the post-test, they can no longer navigate back to the training. The students will be required to complete the full module to include the training and both tests within a 3-hour time span. The tests will be embedded within the online module, and the responses will be coded using statistics software. Once a student hits submit on both the pretest and the post-test, their responses will be recorded and graded. After the study concludes, the scores will be exported to a spreadsheet that shows the scores for every participant in each group and for each test. Internal consistency will be evaluated by correlating performance on each test question with overall performance. Cronbach's alpha will be calculated to establish evidence of internal consistency reliability. This form of reliability evidence is looking at how unified the test questions are and how they relate to the overarching theme. In this case, the test questions should all pertain to the user functionality of ConIT. Content validity will be evaluated to ensure that the test questions are representative of the complete set of information. The questions used in the study will be designed to be representative of the full extent of ConIT information while still keeping the number of questions to a reasonable amount. We will have ConIT subject matter experts review the questions to determine if this is the case. If yes, this helps to establish evidence of content validity. An independent samples t-test will be used as an inferential statistic to determine the differences between the two groups. The easiest way to do this will be to take the spreadsheet of test scores from both the control group and experimental group and calculate the t-value. This can be done in Excel using the tool pack. From there, we will be able to determine if the results of the study are statistically significant. In order to interpret the statistical significance, we will examine the standard variation to determine if there is a lot of variation, as well as the magnitude to determine the effect size. And this concludes this quantitative study design. Thank you for joining me today.